Hi guys, had a request from Eddie Goddard to 3D print him a pulse motor because he'd seen I'd done some. Two things about that. One, I don't do commissions. People ask me to make things for them, I don't do it. I have made a few things for friends and relatives, but other than that, I don't want to get involved in printing stuff and charging people money for my time. People also seem to forget that people's time is the most expensive bit. You probably couldn't afford my hourly rate. Anyway, that's a side issue. What I said was pulse motors are really around making things from what you find in the house, everyday items. If you have a look at LidMotor's channel, he does lots of pulse motors. Lots of people do pulse motors, but LidMotor's a good example because his channel name, LidMotor, arises from the fact that he used to make them from lids, from various containers. So you have a plastic lid, you need some magnets. Now these magnets here, I have some toys, magnetic toys, that have these little arms in them with magnets in each end. And as you can see, I've harvested quite a few little neodymium magnets. They don't have to be neodymium, but neodymium are stronger, so they work easier. You could glue them in place, or if you get a couple of them, you can put one on the inside and one on the outside, and they will hold themselves in place. If you have a suitable shaped lid. This one isn't ideal because it's got little ridges around the outside and a big thread on the inside, but we might be able to make it work like this. Two, or in this case four, two either side is probably the minimum you want. And you see people with 6, 8, 10, loads of them. Can't even get that one apart. And that one's jumped over there. You could use double-sided sticky tape to hold them in place, stop them jumping around. I'll sort that out in a minute, but we'll go on with what we're talking about. Next thing you need is a circuit to give you a pulse of current. Obviously you need a coil of some sort. You need to either wind a coil by taking some wire and winding it. LidMotor uses sewing machine bobbins. You can get them in plastic, and they're convenient little spools to wrap wire around. If you want it to be really low power, then you need very thin wire. If you're not worried about keeping it to a low power usage, then you can use thicker wire and a bigger battery. So then you need something to actually send the pulse of current to the coil. And probably the easiest option, well, there's two easy options. One easy option is you mechanically have something that touches, if that's a contact and that's a contact, maybe this could be attached to the wheel as it turns, and as it hits that contact, it makes the circuit and you get a pulse of current. So that'd be one way of doing it. A common way is to use what's called a reed relay, which is a pair of springy bits of metal encapsulated in a glass tube, and as the magnet goes past, they're attracted, and that makes the contact. The only problem with them is they tend to spark if you're using too much current, and they weld themselves together eventually. Another way of doing it is get a solar rocker, pinch the circuit board out of it and the solar panel and the coil, and you can use that. This will give you a working pulse motor. So that's what I'm going to try and do now. I'm going to see if I can get some magnets on there. I'd rather use a bigger plastic lid, but we might be able to use that. Ideally, something like a long needle to go down through the middle to give us an axle. But if you haven't got a long needle, then you should be able to just flatten out a paper clip. And that beeping noise in the background is my tea's ready. So we will carry on after I've had my tea. Right, I really want this to look as rough as possible, so you can see how basic you can make it. As you can see, it's not quite right. But you can see what I've done. I've just got some coffee stirrers here, and I've used the magnets at the top to support the paper clip that I've straightened out. In fact, I just realised that's actually touching on the bottom there. We don't want it there. We want it supported there. So I was saying, yeah, paper clip straightened out in the middle to give us the axle. 4 of those magnets at the moment. Just realised this is slowly drifting over because I've just used blue tack to hold it all together, and it's slowly giving way. It'd be better to glue it. I just wanted to try and demonstrate just how basic you can make it. Those wires are hanging over the front. Right, you don't want that. Should I give it a little bit of help or not? It's not balanced, which means it's tending to hang to one side. In fact, you can probably see how far out of balance it is. I haven't got the pin right in the middle. I may have made this too basic. Oh, nearly got going then, didn't it? So close. I've got all the magnets facing the same direction. Some people say you ought to have them alternating north-south, north-south. The difference is there's less friction if it's attached to the top. If it's standing on the bottom, you've got the weight adding to the friction. Oh dear. Oh, it's dropped again, hasn't it? Well, to be honest, I don't quite believe this is working. Oh, dear me. I mean, it's as rough as I can make it. Oh, that's better. It's stopped. I think it's just, you can see it's slowly tilting over because there's nothing glued in place. And I've got it in north-south configuration, so they alternate, which I don't normally do. I've just changed my bent paper clip for a proper needle. Oh, I was just going to give it a bit of a push, but it seems to be trying to go on its own. Could do with another magnet under the bottom to stabilise it a bit. Because the needle's that much shorter. I think I've got some magnets over there. Oh, is that going anyway? Nearly. Oh, so close. Just going to move the camera a second so I can get to my stock of magnets. I might not need to. It's trying, isn't it? Yeah, let's go in. I won't add any more magnets. Yeah, oh, maybe I should. I just know that if I start fiddling with it, I'll probably knock it over or something. All right. dear. Yeah, because that's stronger. And now pulling the magnets off the side. There we go, it's that little bit more stable. I'll just drop the camera down a bit so you can see what I've done underneath. Right, so you can see the needle's not actually touching the magnets on the bottom. They're just stabilising it, stopping the whole thing rocking around. So that was, I'd gone a bit too rough trying to use a paper clip because I just couldn't get it straight enough. So that's a nice needle. So just say again, the thin point of the needle is sticking to the top magnet, and the thicker bottom end of the needle is just being held in place by the bottom magnet. It's not actually touching it. Then the light is shining on the solar panel, and the solar rocker circuit is sending pulses of electricity to the coil to attract and repel the magnets. I say attract and repel because I've got them north, south, so when it repels one of them, it's attracting the next one at the same time. So it gives you a more efficient run, I suppose. I don't normally do it north, south. I normally just go north, north, or south, south. So I'm interested to see it's working alternate. Yeah, that's dropped now, so it's now dropped to the bottom. It's because this is all slowly giving way under the heat of the light. The blue tack gets softer. Yeah, that'll do for now. I just thought I'd demonstrate using a needle was a better idea than trying to use a paper clip. Thanks for watching. If you want more information, check down below in the video description. If you like this video, you might like this one up here. And if you want to subscribe, you can check out my channel over here. Up here is my latest video on my channel, and down here is a video playlist associated with the video you've just watched. Thanks again for watching.